Namaste and welcome to Apna Gurukul Maths. We are starting a brand new chapter today that is called as linear equations in two variables. And this is the chapter number 4 of NCERT class 9th maths. Let's begin. So linear equation in two variables, and before we start that, first of all, are we clear with linear equation in one variable? First of all, are we clear with equations? Now, equations are nothing but the expressions with a value, right? We have already learned what is an equation while we were discussing polynomial. So whenever we give a value to an equation, value to an expression, it becomes an equation. It is linear if the power, if the degree, if the maximum power is 1. So many times I used maximum power of the expression is 1. That means linear. So I hope that we are clear with linear equation in one variable. Very quickly, I'll take an example. Suppose I have 2x plus 5 equals to 0. This is a linear equation in for one variable. What is the solution for that? The solution is we take the value 2x equals 5 goes to the other side, it becomes minus 5, x equals minus 5 by 2. So x equals minus 5 by 2 is the solution of this particular linear equation in one variable, and obviously it can be plotted on the number line. We already know how to plot the plot a rational number on the number line. Now there are two things we must understand while we deal with equations, that no matter what you add or multiply in the equation, if the same operation is done on the left hand side and right hand side, that does not change the equation, and we are allowed to do so. So if you are doing the same operation on both sides of the equation, it's perfectly allowed, and we can very comfortably do that. So that is one thing we must always remember. Now let's try to take a few example of two variable equations. Okay, two variable example, 21x plus 12y equals 10. Obviously there are two variables and it becomes a two variable equation. And the next equation, as you can see, 6x plus y equals 17. So obviously it's a one variable equation. Sorry, two variable equation. 7x plus y cube equals 156, two variable equation. Now as you can see, this one is not a linear polynomial because it is y cubed. It's not a linear polynomial, but obviously since there are two variable, it's a two variable equation. Then 3x plus 5y equals 13, 2x square plus 10y. As you can see, everywhere I have x and y as the variables, so this becomes two variable equations. Now we have to focus on two variable linear equations and then two variable linear equations. So let's try to define that. Any equation which can be put in the form of ax plus by plus c equals to 0, where a and b are rational number and a and b are not both 0. What is the meaning of that? At one particular time, either of them can be 0. A can be 0 or b can be 0. At the same time, both cannot be 0. Like a and b both cannot be 0 at the same time. That is what is the meaning of a and b are not both 0. Okay, that is what is the definition of linear equation in two variables. Very quickly, any equation which can be put in the form of ax plus by plus c, where a and b are real numbers, a and b are not both zeros. These are the two conditions about this particular equation. So now let's try to take a few examples and try to understand, try to verify or try to identify linear equation in two variables. As you can see, 2x plus 3y equals to 4. I can write them as 2x plus 3y minus 4 equals to 0. Is it in the form of ax plus by plus c equals 0? Absolutely yes. So this is a linear polynomial into linear equation in two variables. So then x minus 4 equals root 3y. Now root 3 is a real number, right? So what is the what does it say? A, B, C, A, B are real numbers. So obviously it can be, can I write it in the form x minus root 3y minus 4 equal to 0. So obviously it can also be written in the form of ax plus by plus c. So this is also a linear polynomial, linear equation in two variables. 4 equals 5x minus 3y. We can write it as 5x minus 3y minus 4. Why am I getting minus 4 every time? No worries. So this is also a polynomial. This is also a polynomial. 2x equals y. I can write it as 2x minus y minus 0 equals 0. So over here, the value of c is 0. So obviously, 2x equals y is also a linear equation in two variables. Yes. So one thing we have to observe here is equations of the type ax plus b is equals to 0 are also examples of linear equation in two variable because they can be expressed as ax plus 0 y plus b equals 0. Yes. Now what do we understand here? We understand the real meaning of a and b are not both 0. As you can see here, the second coefficient is 0, but one of them is not 0. That is non-zero. So that is why ax plus b equals to 0 is also a linear equation in two variables because the other variable has a coefficient of 0. That is what is our understanding. Now let's try to understand what is the meaning of solutions of linear equation in two variable. The meaning of solutions is solution means what are the value of x and y such that the LHS becomes equal to RHS. Now, what exactly do we mean by the solution? So x plus 2y, whenever we have linear equation in two variables, when we plot its graph, it's always a straight line. So the solution means all the possible points on that graph are nothing but the solution of this linear equation in two variable. We'll we'll look into that after some time. But before that, solution of linear equation in two variables. Suppose we have x plus 2y equals 6. We want its solution. So what do we do is we put any random value of x, right? We will put x as 0. Now, in this particular equation, when we put x value as 0, so now our equation becomes 0 plus 2y equals 6. So y will be, or 2y equals 6. Y is equals 6 by 2, that is equals to 3. So when the x value is 0, y equals 3. So the coordinate 0, 3, the coordinate 0, 3 is the solution of this linear equation. Is there any other solution possible? Absolutely. I can give any other value to x. Let's give the value of x as 2. Let's give the value of x as 2 and try to see what happens. So I give the value of x as 2 and let's try to understand what happens. So 2 plus 2y equals 6. 2y equals 6 minus 2. 2y equals 4. That implies y is equals to 2. That means if the x is 2, y is also 2. So 2, 2 is the other coordinate, which is the solution of this particular linear equation. Now my question arises, how many such solutions are possible? Yes, you answered it correct. Infinitely many. The number of values we give to x, that many number of y's, the values of y we will get. How many possible values can we give to x? Infinitely many. So possible value of y will be infinitely many, and therefore infinitely many solutions are possible for all of these equations. You can try out to find two or three solutions for these equations. Yes, I hope that makes sense. Now let's try to understand how do we make the graph of the equations. So again, I have one equation, 2x plus 3y equals 8. So first thing we do is we have already discussed in the previous chapter. I took one example. If you are not clear with that, you can go through that video. I have the link in the description. So first thing we do is we make this table where we write at least three solutions of this equation. Yes. So let's take the value of x as we will take the value of x as 1. If I take the value of x as 1, so over here it becomes 2 times 1 plus 3y equals 8. So 2 times 1 is 2 plus 3y equals 8. That implies 3y equals 8 minus 2, that is 6. So if 3y is 6, y will be 2. Yes, that is one solution of this linear equation in two variable. Let's take another point of uh, this x. Let's now take it to be minus 2. Okay, I will take the value of x as minus 2. So if I take the value of x as minus 2, what happens? 2 times minus 2 plus 3y equals 8. Yes, so 2 times minus 2 is becomes minus 4 plus 3y equals 8. Now I take this to the other side. So 3y becomes 8 plus 4. 3y equals 12. So that implies y equals 12 by 3. So that is nothing but 4. So y value will be 4. Now, my dear students, to plot the graph, we only require 2 points, because from on this particular Cartesian plane, we need 2 points to make one unique line. Every time it is possible, but for verification, we generally take 3 points. We will try to understand how do we make points only with two graphs, and then we will obviously do 3 points as well for verification purpose. The third point is generally for verification, if your answer is correct or not. So now let's try to understand, with the help of this table which we have drawn, how do we plot it on the graph, plot the point on the graph. So as you can see, x is going for 1, and then it is going, so x1 comma y value is 2. So it will be, the first point will be here. The point is a little bit bigger according to the graph, but for your understanding, I'm taking it a bigger. X is minus 2 in the second point, and then it goes up to 4. Now it goes over here. I hope you are very much clear how to plot the points on this particular graph. Now we will connect this, and then we will extend this line a little bit bigger, and then we extend this line a little bit bigger on the top. So this particular line is the solution line for 2x plus 3y equals to 8. This is also called the graph of linear equation in two variable. Let's try to understand one more example. Y is equals 4x plus 2. Okay, so y is equals 4x plus 2. Obviously, the first thing we do is we try to plot, find a few solutions. That is, we generally make 3 solutions. So let's change the ink and then try to make this table. So x comma y. So obviously we will try take the value of x as 0. So once we take the value of x as 0, y value we get it as 2. Once we take the value of x as 1, so 4 times 1 is 4 plus 2 is 6. We will take the value as minus 1. So x value, when we take minus 1, 4 times minus 1 is minus 4. Minus 4 plus 2, minus 4 plus 2, you will get it as y equals minus 2. So these are the 3 coordinates we got. Let's try to plot it on this particular graph. Okay, on the same graph we will plot it. Okay, so on the same graph, 0 comma 2, x-axis is 0, y-axis is 2. So this is 1 point. X-axis is 1 and y-axis is 6. So this is the other point. Now the third point is minus 1 comma minus 2. Minus 1 is the x-axis and minus 2 is the y-axis. So this is the point. Let's try to connect all these 3 points with one line. Yes, you are able to do it. So when you have 3 points to plot, we in a way verify it directly also. So this is the line which is the solution for, which is the graph for the equation y equals 4x plus 2. Yes, you can try this third equation, 4x plus 2y, on the graph by yourself and with the help of 3 tables. Yes. Now, how does the solution or the equation of a line parallel to x or y axis look like? Okay, that's might be a question. So I tell you, it looks like x equals to 4, y equals to minus 5. Or similarly, any coordinate, any axis is equals to some number. Now, why is that so? Let's try to understand. Now, this particular equation x equals 4, it can be written as x plus 0y equals to 4 to make it into standard form, or we can also write it as minus 4 equals to 0. Now, what is the value of y can we give? Because x value is fixed, x value is 4. We can give any value to y because 0 times any value of y will always be 0, right? So what would be the table of this particular graph? It will look something like this. So x value, y value. So the value of x is 4 and it's fixed every time. The value of y could be 1, 0, minus 1, anything you can take. So let's plot this on the graph. So the value of x is fixed, that is 4. The value of y, we took it as minus 1, and then we took it as 1 and then 0. So what will that line look like? That will be parallel to y axis. So if a line is parallel to y axis, its equation will be in the form of x equals a. Okay, so you can quickly make a note of that. Line parallel to x axis, parallel to y axis, I'm sorry, y axis, it will have an equation which is of the form x equals a or x equals minus a. Both works, right? So for example, you can take once again x equals, suppose I have minus 6. So what will be the table look like? Table will look like the value of x is fixed. So x and y, the value of x is 6, minus 6, minus 6 and minus 6. So this equation, when we try to write in standard form, how will that look like? That will look like x plus 0 times y equals minus 6. Now since this is 0 times y, I can take any value of y. So 1, 2, 0, or any big value also we can take. Like, let's try to plot this on this graph. X value is minus 6 and then 1 and 2, 0, or we can take any value over here. So that, how will that equation look like? The equation will look something like this, right? So now if I ask you to plot y equals, this one is one of the most easiest topics of you could ever think of. If I ask you to plot y equals minus 9, how will the graph look like? Minus 9. So why the value of y is same, right? So once again, plot the table x, y. So the value of y is always minus 9. It is not going to change because that's what the equation says. This can be 0, this could be 10, this could be 8. Any number it can be, because again, what will be the standard form? 0 multiplied by x plus y equals minus 9. Yes? So now let's plot the point. So it will be minus 9. Minus 9 is over here. So 0 comma minus 9 is here. Then 10 comma minus 9 is over here. And then 8 comma minus 9, 8 comma minus 9 is over here. Now when you connect this point, you will get the graph of, this is the graph of y equals minus 9. So what is the understanding here? If we have a line parallel to x-axis, line parallel to x-axis, what is the equation look like? Line parallel to x-axis, the equation looks like y equals to a, or it also looks like y equals minus a. I hope that is very, very much clear to all of you. So this is what is equations of line parallel to x and y axis. So what do we mean exactly by the solution? I told you that we will discuss this in detail. Now, let's suppose I have plotted a point which is x plus y equals to 2 on this graph with the help of a graphing calculator, Geogebra graphing calculator. Now what happens? X plus y equals to, that is the graph. Now, if I mark any point on this graph, let's see, I have marked this point A, B, C, D, E, F. I have marked 6 different points. Let's try to observe these 6 different points. Now, what is the equation says? X plus y equals to 2. Now, their coordinates must add up to 2. Let's try to. A is minus 2 comma 4. Minus 2 plus 4 is 2. B is minus 1.43 and 3.43. Minus 1.43 and 3.43 is obviously 2 once again. Then C point is minus 0.5 and 2.5. As you can see here, it is all written over here. Minus 0.5. I'm not reading the whole number. It's a very big decimal. I'll just read minus 0.5 plus 2.5. What will be that? It's obviously 2. Then the point D is 1 comma 1. 1 plus 1 is 2. Point E is 1.5 and 0.5. 1.5 and 0.5 is once again 2. Point F is 2.6 and minus 0.6. So 2.6 minus 0.6 is obviously 2. So that is what means the solution of the linear equation in 2 variables. That means whenever we plot the graph, no matter what point we take, it will satisfy the equation. What is the meaning of satisfy the equation? LHS will come out. LHS will be equal to RHS. Yes. So this is the basic things which are there in this particular chapter, that is linear equation in 2 variable. We don't have to go for any other type of solution. We just have to focus on graphical solution at the level of class 9. Now, we will take a few example of exercise 4.3. We will try to make equation from word problems and then plot their graph. Okay. Are you guys ready? We will take 3 problems, but these are just, I have just copy pasted the questions from the book, and that's why that bookmark also you can see the NCERT as well. So let's first understand if point 3 comma 4 lies on the graph of the equation. Now, just now we saw, right? If it lies on the graph, that means it will satisfy the equation. That means it will make the LHS equals to RHS. So what is the equation we have? 3y equals ax plus 7. And what is the point? 3 comma 4. That means this point will make LHS equals to RHS. So that's how we have to find the value of a. So 3 times what is the value of y? 4. A times what is the value of x? It is 3 plus 7. So 4 times 3 is 12. That is equals a times 3 is 3a plus 7. Now plus 7 goes to the other side. It becomes minus 7. So 12 minus 7 equals 3a. 12 minus 7 is 5 equals to 3a. Now 3 multiplied by a, when it goes to the other side, it becomes division. 5 by 3 equals a. And that's how we get to the value of a. So when you get such a question, you can be thorough. That is how we have to approach the problem according to what is the meaning of the solution. And that's why I showed you with the help of a graphing calculator. Okay, now let's understand the 4th question, how to make an equation. Already we have been doing a lot of word problems, so I hope that you are very much clear with how to make the equation, but still we will do three problems, and that will make it very much clear, and that will be the end of this particular chapter. So the taxi fare in a city is as follows. For the first kilometer, the fare is ₹8, and with the subsequent distance, it is 5 kilometers per hour, taking the distance covered as x kilometers. So total distance is x kilometers. The total fare is y. So total fare is y. Now y will be equal to first kilometer, it is 8 rupees. It is fixed. Now for the first kilometer, 8 rupees is fixed. Now for the rest of the kilometer. So what is the rest of the kilometer? Total distance is x minus 1, right? So that is x minus 1 is the rest of the kilometer which is left for us. I hope that makes sense. I will clarify. Y is the total fare. So total fare will be first kilometer and after for the rest of the kilometer, because first kilometer it is ₹8. Yes, so you have to be thorough with that. So ₹8 is the first kilometer plus 5 rupees after that. So 5 rupees x minus 1. Why did I take? Because for first kilometer I have already taken x 8 rupees, right? So there I won't count 5 rupees, otherwise I'll be giving 5 rupees extra. Okay, so now that equation, let's make it into a standard form. So this becomes 8 plus 5 will be using distributive property. So this becomes 5x minus 5. So y is equals to 5x. 8 minus 5 is 3. I hope that makes sense. Yes, now we will make the table x and y columns. We will try to plot 3 points. As I asked you, 2 points is enough, but third point we mark it as a verification. Okay, so x and y we have. So if I take the value of x as 0, if I take it as 0, what I mean, y equals 3. So how are we calculating? Y equals 5 times 0 plus 3. So y equals 5 times 0 is 0 plus 3. 0 plus 3 is 3. And that's how we get the value as 3. If I take x as 1, I get 5 times 1 is 5 plus 3, 8. If I take the value of x as we won't take minus 1 because minus 1 as a distance, that does not make sense. So and if we take 2, 5 times 2, and the graph leads us to 13. Okay, so our graph is not that big enough. Over here we have till 18, so only 10. So you can just adjust your graph accordingly, no problem with that. Let's try to plot this point. X is 0 and y is 3. So this point is somewhere here. X is 1 and the graph is 8. Yes, graph is at 8. So now when it is 2, it is somewhere crossing over here. It's going to 13. Let's make this particular graph complete so that it goes on and on and on, and that's how it goes over here in this side as well. Yes, and that's how, no, this graph does not look, so it needs to be a straight line, so I will make it a straight line, and this graph becomes the graph of our equation, that is y equals 5x plus 3. Yes, that is how the graph will extend. Now, whatever point you take, we can directly tell what is the fare, what is the distance, and how much will be the fare, and that makes this solution much more impactful. Now you might be thinking, where do we use such things? Now don't use it, but the car companies, the cab companies like Ola, Uber, and all those companies always try to use these equations we discussed, right? Now when we have the variables and we know how to operate on these variables, it becomes easier for us to calculate things, and graph is one of the best ways to calculate things. That is why we are learning how to find the solutions of linear equation in two variables on the graph, because once we have learned on graph, the other things becomes a little bit easier, and obviously it makes much more sense to learn that. Okay, so that is why that was the first question. The second question, okay, which is a similar one, not exactly similar, but yes. So if the work done by a body on application of a constant force is directly proportional to the distance traveled by the body, so let's take work done as y, and let's take the distance traveled as x. So that y, according to the question, y is directly proportional to x. And what is the constant force? So we can write the equation as y is equals x, and there is some constant force, and it is given as constant force is 5 units. So y is equals 5x. That is the equation we have. Now let's try to plot the graph. 10, 10, 10, 3 points, x, y, and then we plot the value of x as 0. So if the value of x is 0, what will be the value of y? It will also be 0. If the value of x is 1, the value of y gets to be 5. If the value of x is 2, the value of y becomes 10. Yes, that is how the equation goes. So we will try to plot it on the graph. So 0, 0, the first point is here, then 1, 5, the second point is here, the third point is 2, 10, the third point is here, and our graph looks like this. Yep, it is passing through the origin. Now, what's the next question says? If the work done is 2 units, also read the graph, work done when the distance traveled. When the distance traveled is 2 units. So that means D is, if it's 2, if the D value is 2, that is X is 2, what is the Y value? It's obviously 10. So that implies 10 units. If the work done is 0, it's obviously 0. We can see from the table itself. Okay. Now, once we have the graph, we can find any kind of value you want, and that's how we plot the graph. This is the 6th question of exercise 4.3. Let's move on to the 8th question and the major question which all the students and all my students get confused with. So please pay attention. Over here, there is a very important conversion given which is used pretty often every day when we read the newspapers. Over there, we have Fahrenheit and Celsius scales of temperature, right? So every day this calculation, this conversion is used. So what is the conversion? Fahrenheit is equals to 9 by 5 Celsius plus 32. So over here it is asking us take Celsius as x-axis. I'm sorry. Take Celsius as x-axis. So Fahrenheit is y, 9 by 5 times Celsius is x plus 32. Yes. So that is what is the conversion we have. Now let's make the table to make the graph, and then we will try to answer all the questions. Okay. So we will first make the table. Now over here, as you can see, there is fractions involved. So we will take the value of x in such a manner that we don't get fractions, because it is little difficult to plot fractions. So what I'll take is, I'll take the x value as 0. So I'll get it as 32. I'll take the x value as 5, because 5 and 5 will cancel out. So if I take the x value as 5, so y will be equal to 9 by 5 times 5 plus 32. So 5 and 5 gets cancelled out. 32 plus 9, I'll get it as 41. So I get it as 41. If I take the temperature as minus 5, I'll calculate it and I'll get minus 9 plus 32. I'll get it as 24. Yes, let's try to plot these few points on this graph of this particular. Let's try to convert it into graph. So 0, x value is 0, and we have to move on 32. That's our first point. That is our first point, 0 comma 32. The second point is 5 comma 41. 41 is a little difficult to make, so we will avoid with that. Minus 5 comma 24. Minus 5 comma 24, and here our graph comes. So let's extend this graph with the 2 points, and let's see where do we go. Yep. And then our graph goes something like this. Just a second. And our graph goes something. Wait, what's happening? Yes, our graph goes something like this. Yes. So our graph is looking something like this, and this is the graph for y is equals 9 by 5 x plus 32. Now you can observe very clearly, I told, right, third point acts as a verification. Now 5, it should be little up than 41, and you can see it because there is an 8 differentiation between this, so it should be a little bit up to that. So that acts as a verification point. Now that is how we plot the graph of this particular equation. Let's try to answer all the other questions. If the temperature is 30 degrees Celsius, what is the temperature in Fahrenheit? So you can do that with graph, but since graphing will be a little bit difficult, because otherwise we have to make the graph more and more accurate, we will try to use the linear equation concept over here. So now, if the temperature is Fahrenheit degrees Celsius, so now we will get back to the original equation. F equals 9 by 5 times C plus 32. So now it says temperature is 30 degrees Celsius. So instead of C, we will substitute 30. F equals 9 by 5 times 30 plus 32. So 5 times 6. So 9 times 6 is 54 plus 32. That will be Fahrenheit. So Fahrenheit over here becomes 4 plus 2, 6, 5 plus 3, 8. So that will give us 86 degree Fahrenheit. Yes. So that is what is the conversion. Now, if the temperature is 95 degree Fahrenheit, what is the temperature in Celsius? We will quickly do that. Wait just a second. Why did I erase the formula? So Fahrenheit is given. Now we have to convert it into Celsius. Quickly do that. Instead of Fahrenheit, we substitute 95. That is equals to 9 by 5 times C plus 32. Now your question might arise, can we take this 5 by 9 directly to the other side? No, no, my dear friends. Why? Because there are two different terms. So we have to first take this 32 to this other side. So this becomes 95 minus 32 equals 9 by 5 times C. So 95 minus 32, 5 minus 2 is 3, 9 minus 2 is 6. 63 equals 9 by 5 times C. Now we have only one term. We can take this to the other side. So 63 times 5 by 9 equals to C. So 9 times 7 and 7 times 5 is 35. So we get to the answer as 35 degrees Celsius. Yes. Now, if the temperature is 0 degrees Celsius, what is the temperature in Fahrenheit? So, as you can see from the graph also, if the temperature is 0 degrees Celsius, it should be no, wait, 0 degrees Celsius. That Celsius was x-axis, right? So it should be 32 degree Fahrenheit. Let's see if we get to that point. So x, the value of Celsius is taken as 0. So Fahrenheit equals 9 by 5 times 0 plus 32. Now 9 by 5 times 0 is 0. So Fahrenheit equals 32 degrees. Yes. So that is how the fourth question goes. Now fifth question is very beautiful question. Let's try to answer that. It says, is there any possibility of a temperature where both temperature, the Celsius and the Fahrenheit, are equal? If yes, find the temperature. Now, one thing you can do is you can extend that graph and try to find it out, or we can substitute it in directly the graph. Extending the graph is possible when we have a little bigger graph. I will show you that also. So let's try to do with this one first. So what does it say? Fahrenheit equals to Celsius. So instead of Fahrenheit, I will make it as Celsius because both are to be equal. 9 by 5 times Celsius plus 32. So what do we get? Celsius minus 32 equals 9 by 5 times Celsius. Yes. So I'll take this 5 to the other side. So 5 times Celsius minus 32 or C minus 32 equals 9C. So now this is distributive property. I'm just using the normal equations rules. Okay. Don't get confused that I'm using so many things. 5C and 5 multiplied by 32, 5 times, it will be obviously minus. 5 times 2 is 10, carry over 1. 5 times 3 is 15 plus 1, 16. That is equals to 9C. So we will take this to other side. Minus 160 is equals 9C minus 5C. 9C minus 5C is 4C. 4C equals minus 160. 4 is in multiplication. When it comes to the other side, it comes in division. Minus 160 by 4 equals to C. So when you divide, you get it as 40. So the value of Celsius would be minus 40 degree Celsius, and the Fahrenheit will also be minus 40 degrees Fahrenheit. So at minus 40, the conversion of degree and Celsius are exactly the same. And that is what we were looking at. I hope that makes complete sense. I hope this chapter is very much clear to you all. If you still have doubt, please comment down. We will have a further discussion on that. Thank you so much for being with Apna Gurukul Math for so much time and learning this amazing chapter. I hope you understood. I hope you enjoyed this chapter. Thank you so much. See you in the next video. Until then, keep smiling. Jai Hind. Now, as I told, after this particular chapter is over, I will show you. Let me make one more graph. I will refresh it. And then I'll make the same calculation. Okay, same algebraic table, Celsius and Fahrenheit conversion, and let's try to understand it in a little bit detail. Okay, so we have the equation y equals 9 by 5 is nothing but, I'll write it in points, 1.8x plus 32. Yes, so if I make the graph smaller, as you can see, it is looking like this. So when you look it into detail, you will find that it is going like this, and the graph moves accordingly. No matter what point you want, you can very easily reach that point. You can maximize it, you can reach that point and try to see that at minus 40 times 40, see, minus 40 and 40, this point is equal, and that is what we calculated, right? I will mark this point, just give me a moment. Minus 40, wait, what is the point? Minus 40 comma 40. Yes, as you can see, this is a point on the graph. Yes, so that means this point is on the graph, and as well as the value of x and y are equal. So that is what we calculated. You can try actually enjoy everything on this particular graph. This is a very beautiful graph. You can try it out, a graphing calculator by Geogebra. You can enjoy with this a lot. Thank you so much for being me with a little extra time. See you in the next video. Bye bye.